At a Beijing Expo designed to showcase industrial prowess, a flagship fire truck gave a truly unforgettable performance by dramatically snapping in half. As staff scrambled to literally cover up the wreckage, they couldn't hide a much wider problem of quality control. But the company's official excuse for the disaster was even more flimsy than their aerial ladder.
It's normal for industrial products to have defects, but this happened at an international exhibition. And it was a fire truck, not an ordinary machine. Fire trucks are meant to save lives. If even the display vehicle at an exhibition has such a major failure, a broken aerial ladder, that's a serious problem.
From October 13th, Beijing hosted a major conference. It was the 21st China International Fire Protection Exhibition. The event's theme was Empowering Practical Combat with Technology. It covered over 150,000 square meters of exhibition space. The event was intended as a showcase of industrial prowess. Instead, a catastrophic failure occurred on the morning of October 14th. A domestically produced DG28 aerial platform fire truck failed. It was a flagship model from a leading Chinese manufacturer. The truck's aerial ladder suddenly and completely snapped. Onlooker videos captured the boom breaking near its base. The entire structure collapsed onto an adjacent airport fire truck. A staff member later downplayed the severe damage. He said,
"The damage isn't too severe. It can still run and just needs repairs."
The immediate aftermath was a public spectacle of engineering failure. Crowds gathered to document the wreckage. Staff scrambled to conceal the damaged vehicles under large cloths. The clumsy attempt to hide the physical wreckage under a giant cloth only magnified the reputational damage. A Chinese media outlet, stdaily.com, sarcastically pointed out the only good news: the company's truck had only managed to smash another of its own products without killing anyone. But while the company's staff fumed, the most damning verdict came from the international buyers the Expo was meant to impress, who offered a simple reaction to the engineering marvel, a smile that spoke volumes. A Chinese netizen offered a sharp technical analysis.
The most technically sophisticated part of a fire truck is its chassis. Nearly all domestic aerial and phone fire trucks use imported chassis from 4 major brands: Scania and Volvo from Sweden, and Mercedes-Benz and MAN from Germany. From the video you can see that this truck was also built on a Scania chassis. The key technology has already been solved through imports. Yet, Chinese manufacturers still failed to properly produce the rest of the vehicle, and this is a fire truck. Unlike other engineering machines, it cannot afford to malfunction. After the incident, whether it was the organizer or the brand representative, the first thing they did was grab some fabric to cover up the accident site. What was supposed to be a cheerful exhibition turned into a major embarrassment. I imagine the brand will have a hard time recovering from this.
A detailed report on October 15th identified the company involved as Weihai Guangtai Airport Equipment Limited Company. Founded in 1991, Weihai Guangtai is a major player, a global leader in airport ground equipment. It exports products to more than 10 countries. Records show the failed model was the DG28 aerial platform fire truck. It was developed by Guangtai's subsidiary, Beijing Dazhuo Firefighting Equipment Company. The vehicle was designed for critical rescue missions. Its purpose was for narrow streets, ancient building complexes, and viaducts. Just 1 month prior, in September, Weihai Guangtai's official WeChat account had heavily promoted the DG28. An article titled, "Weihai Guangtai invites you to the 21st China International Fire Protection Exhibition," specifically showcased the vehicle. This makes the company's post-failure response even more striking. A representative called the DG28 an experimental product. He stated, "We were mainly conducting a lightweight study, claiming it has not been mass-produced." This explanation directly contradicts its marketing as a pioneering product. Many online commenters noted another key detail. The damaged airport truck closely resembled a Panther fire truck. The Panther is made by Austria's Rosenbauer Group. This suggested the Guangtai vehicle was likely a copy. The Rosenbauer Panther is a high-performance chemical fire truck. It is used at airports and petrochemical plants. The vehicle is valued at over $1 million. Its unique nozzle has a powerful flow rate. It can discharge up to 6,000 liters per minute. This is 6 times greater than that of traditional fire trucks. The failure was a public indictment of the product's engineering. An eyewitness confirmed the sudden nature of the event. He said,
"The wind was not strong at the time. There was no warning. The ladder suddenly broke from the base."
The reporter noted that multiple attempts to contact the exhibition's organizing committee for comment were unsuccessful, as the calls could not be connected. For a piece of mission-critical equipment, this was a damning verdict. The incident at a global technology showcase revealed a dangerous gap. It exposed the space between industrial ambition and engineering capability, a gap that begins at the very foundation of the vehicle. The foundational bottleneck, the chassis. The chassis stands as the foundational and most critical bottleneck in China's ambition to produce high-end fire trucks, representing far more than a simple vehicle frame. It is a specialized, high-performance engineering platform where the technological gap is most quantifiable. An analysis of the domestic manufacturer Haomiao Technology on ofweek.com provides stark financial evidence. A domestic Halwo truck chassis costs around 280,000 yuan, whereas an imported Mercedes-Benz Arux or Zetro series Sashi, purpose-built for firefighting, commands a price of over 1.2 million yuan. This fourfold price difference is justified by significant engineering disparities that are non-negotiable for high-reach applications. High-end imported chassis from brands like Mercedes-Benz, MAN, and Scania feature purpose-built, reinforced frames with exceptional torsional rigidity, specialized suspension, and integrated outrigger systems engineered to provide an unyielding platform under the immense dynamic loads of a fully extended, water-spraying ladder. A critical component is the high-capacity, engine-driven power takeoff (PTO) unit, designed for continuous, high-torque operation to power the massive hydraulic pumps, a stark contrast to the often adapted commercial truck chassis used for lower-tier domestic models. His PTOs are typically rated for intermittent use. As the OF Week report notes, the chassis alone can account for approximately 45% of a fire truck's total raw material cost, making it the single most significant factor in both performance and price. Beyond the chassis, China's domestic fire truck industry lags significantly in the mission-critical upper structure technologies, a domain where systems integration, material science, and control software are paramount. According to an article on Jihu, this deficit extends beyond basic hydraulics to encompass the entire integrated system, including high-precision proportional valves, high-pressure hydraulic pumps, and the complex programmable logic controller systems required for safe operation. Key components, such as digitally controlled water cannons and the complete aerial ladder assemblies for trucks operating above 50 meters, are still heavily reliant on imports. The catastrophic failure of a Weihai Guangtai DG28 aerial ladder at a 2025 Beijing Fire Expo serves as a stark case study. The company admitted the unit was an experimental product from a lightweight study, highlighting the immense risks and material science challenges involved in developing these systems domestically. An analysis of Haomiao Technology on ofweek.com reveals a common business model where Chinese firms act as integrators rather than end-to-end developers. They procure the chassis and critical subsystems, hydraulic, electrical, externally, while self-manufacturing the less technologically demanding structural components. This creates significant systems integration challenges. A key differentiator for foreign brands is a holistic design philosophy, where the chassis and superstructure are developed concurrently, ensuring seamless communication over a CAN bus network between the engine's PTO, the hydraulic pumps, and the ladder's control interface. This integration is crucial for safety-critical features like automatic leveling, load sensing, and envelope control, which prevent catastrophic failure. This performance gap is starkly illustrated by procurement choices. As reported by Autohome's Che Jihao, in 2021, China imported 121 high-end fire trucks for 114 million yuan, averaging over 6.7 million yuan per vehicle. The pinnacle of these imports is the Bronto Skylift F104 HLA, a model renowned for its articulated boom design that offers superior maneuverability. This unit, which can cost up to 24 million yuan, about 3.37 million USD, is built with high-tensile, lightweight steel alloys that require specialized welding techniques to maintain structural integrity, a significant manufacturing hurdle. While domestic firms like Sany Heavy Industry have achieved notable feats, such as a Guinness World Record for its JP100 prototype, spraying water to 159.6 meters. These are often technology demonstrators rather than proven, reliable, and commercially available platforms. Ultimately, the technological gap is perpetuated by market economics. As the Autohome analysis points out, the high-end aerial apparatus market is a low-volume, high-mixed niche, with only a few hundred units imported annually. This makes the staggering R&D investment, spanning material science, control software, and long-term reliability testing, commercially unviable for domestic giants like Sany, Zoomlion, and XCMG, who can achieve much higher returns in the mass-market construction machinery and low to mid-range fire truck sectors. The business calculation is clear. For a 30-meter water tender, a modified domestic commercial chassis is good enough. For a 100-meter aerial platform where lives are on the line, the engineering complexity and liability risks demand a level of investment and specialization that the market structure does not currently support domestically. Consequently, the industry is locked in a state of strategic dependency, with the consensus from multiple industry reports being that the potential for domestic chassis substitution is small. Concerns over domestic manufacturing quality extend to other sectors, notably the electric vehicle industry. Industry giant BYD, for example, has faced scrutiny over quality control. On October 17, 2025, BYD filed a major recall with China's State Administration for Market Regulation for a total of 115,783 vehicles. The recall was split into two batches: 44,535 Tang DM models produced between March 14, 2015 and July 31, 2017, and 71,248 Yuan Pro electric vehicles manufactured between February 1, 2021 and August 31, 2022. The company stated that the Tang models were recalled due to a design flaw in a component within the drive motor controller. This flaw could cause the controller's active discharge function to malfunction, which in extreme cases could lead to the circuit board burning out into complete loss of power, posing a significant safety risk. The Yuan Pro models were recalled for a manufacturing issue where the power battery seal may have been improperly installed. This could lead to reduced sealing effectiveness, allowing water to enter the battery pack if the vehicle is driven through water at high speeds for extended periods. This water ingress could compromise the battery's insulation, potentially reducing its power output and creating a safety hazard. Beyond official recalls, specific incidents have fueled public concern. On July 24, 2025, the hashtag BYD out of control became a trending topic on the Chinese social media platform Weibo. The incident involved a BYD ride-hailing vehicle at the Chengdu Tianfu Airport parking lot that was filmed circling continuously without stopping. While initial social media posts claimed a brake failure, the airport police later issued a statement clarifying that the driver had become emotionally agitated and was driving in circles intentionally. BYD also stated that a vehicle inspection showed the brake system was functioning normally. Despite these official statements, the initial narrative of a vehicle malfunction had already spread widely. A systemic culture of counterfeit. These events contribute to a broader narrative of shoddy projects and quality control issues that permeate various industries in China today, extending from critical public infrastructure to the very materials of daily life. The problem manifests in large-scale foundational projects. In March 2023, residents in the Jihai Haitang community in Nanchang, Jiangxi, discovered their building was serviced by a fake sewage system. A year later, in May 2024, a scandal erupted in Chenchang County over its high-standard farmland initiative. Farmers found that newly installed wells, crucial for irrigation, were merely concrete bases with no actual well drilled underneath, prompting an official investigation. This pattern of systemic deception extends from public works into the materials and products of everyday life, where superficial appearances are engineered to hide worthless cores. In residential construction, what appears solid is often hollow. One clip shows a woman confronting an installer after discovering the solid door she paid for, or a thin veneer wrapped around a core of honeycomb paper. Another exposes a solid wood table as cheap engineered board, skillfully disguised. Whether it's paper in a door or rubble in a tunnel wall, the underlying scam is identical. This mindset of faking quality extends into an industrial-scale culture of counterfeit. A video documents the process of making fake Hotan jade, a highly prized gemstone, from low-cost scraps. The narrator explains the chemical process.
First, these low-cost scraps are sorted. Then they are soaked in chemical potions for dyeing. Look, this is the high-end Hotan seed material you all like. Would you still dare to wear this kind of chemically dyed, high-temperature baked Hotan jade on your body? This chemical potion is dirty and smelly, but the jade dyed with it, every piece is bright and beautiful.
The deception is so profound, it is used to manufacture nature itself. One video reveals how artificial stalactite caves are created, faking geological time with simple construction materials.
Stalactites that take hundreds of years to grow can be made with cement and rags. First, you weld a frame with steel bars, then wrap it with rags and apply cement. Finally, using acrylic paint for coloring, you can achieve the effect of a natural karst cave.
To pass inspections, the fraud must be hidden in plain sight. In one clip, a worker is seen faking the markings on a thin metal sheet, creating the illusion of strength and durability where none exists. From a solid door made of paper to $1 million fire truck that can't hold its own weight, the scam is the same, just scaled up. In this system, the most advanced technology isn't found in engineering, but in perfecting the art of the convincing fake. The real catastrophe isn't a broken ladder. It's the moment you realize you can't trust the ground you're standing on.